Hello everyone. Today we'll introduce the addition rule, which helps us find the probability that one event or another event occurs. Unlike the multiplication rule, which is used for n situations, the addition rule is used for the or situations. The key is recognizing which type of probability question you are being asked. Let's get started. The addition rule is used when either event can occur. The most common keyword that signals the addition rule is the word or. When you see the word or, ask yourself, are we looking for one event, another event, or both? For example, if we want the probability of drawing a heart or a spade, either outcome satisfies the condition. Because we are combining outcomes, we'll use addition rather than multiplication. Here's the big idea. N problems typically use multiplication. Or problems typically use addition. Before we look at examples, we need one important definition. Two events are called mutually exclusive if they cannot happen at the same time. For example, if we draw a single card from a deck, a card cannot be both a heart and a spade. When events are mutually exclusive, the addition rule is very simple. For mutually exclusive events, probability of A or B equals probability of A plus probability of B. Because both events cannot overlap, we simply add the probabilities. For non-mutually exclusive events, probability of A or B equals probability of A plus probability of B minus probability of A and B. In this formula, probability of A and B represents the overlap between the two events. Why do we subtract the overlap? When we add probability of A and probability of B, any outcome that belongs to both events gets counted twice. Subtracting the overlap removes that double counting and gives us the correct probability. As we work through examples, pay close attention to whether overlap exists. If the events cannot occur together, simply add. If they can occur together, add and then subtract the overlap. And if the events A and B are mutually exclusive, then the probability of A and B equals 0. This means if the two events are mutually exclusive, they cannot occur together. There will be no overlap. Let's start with example 3. Question A. If a card is randomly selected, what is the probability that the card belongs to a particular suit? A standard deck of cards contains 52 cards, and there are 4 suits. Each suit contains 13 cards. Therefore, the probability that the card belongs to a particular suit is 13 out of 52. And the question is asking me to leave the answer as a reduced fraction, so I need to reduce this fraction. Both 13 and 52 are divisible by 13, so I divide 13 by 13 and divide 52 by 13. And I get 1 over 4. So the probability of drawing any specific suit is 1/4. Question B. If a card is randomly selected, what is the probability that a card is a queen or a spade? Let's identify our events. One event is drawing a queen, and the other event is drawing a spade. There are 4 queens and 13 spades in the deck of cards. Before calculating, ask yourself, can a card be both a queen and a spade? This is spade, and this is queen. Is there any overlap? Yes. The queen of spades belongs to both groups. That means these events are not mutually exclusive. If we simply add the probabilities together, we count the queen of spades twice. To fix that problem, we subtract the overlap. So we are going to use this formula. The probability of queen or spade equals the probability of queen plus the probability of spade minus the probability of queen and spade. There are 4 queens in the deck of cards. So the probability of drawing a queen is 4 out of 52. There are 13 spades in a deck of cards, so the probability of drawing a spade is 13 out of 52. And there's only one card that can be both a queen and a spade, so the probability of drawing a queen of spades is 1 out of 52. So I take 4 out of 52 plus 13 out of 52 minus 1 over 52, which is 16 over 52. Both 16 and 52 are divisible by 4. So I divide 16 by 4 and divide 52 by 4. And I get 4 over 13. So the probability that the card is a queen or a spade is 4 over 13. Question C. If 2 cards are randomly selected, what is the probability of drawing a face card first, followed by drawing a number card? Notice the phrase followed by. Even though this problem appears in the addition rule section, the keyword tells us this is actually a multiplication rule problem. We want to find the probability that our first card is a face card and our second card is a number card. So the probability that the first card is a face card and the second card is a number card equals the probability that the first card is a face card multiplying by the probability that the second card is a number card. There are a total of 52 cards and 12 face cards. So the probability that the first card is a face card is 12 over 52. The question does not mention if the selection is with or without replacement. So we're going to assume this is without replacement. After the first card is drawn, one of the face cards is removed. Now, we have a total of 51 cards left, and we want to find the probability that the second card is a number card. There are 12 face cards in the deck, and the numbers are from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are a total of 40 number cards. So the probability that the second card is a number card is 40 out of 51. Twelve times 40 is 480. And 52 times 51 is 2652. To simplify this fraction, I'll divide the numerator by 12 and divide the denominator by 12. And I get 40 over 221.